The past few months of teaching astronomy and geology in Alaska helped me draw connections in my understanding of the universe and our world within it. The laws that govern our planet are the same throughout the universe. Let me show you what I mean with a brief history of everything. All the matter in existence roughly 14 billion years ago was extremely compressed into a single entity that, after experiencing such high pressure, reacted by exploding and shooting all matter in all directions, and this is called the Big Bang. After all matter was shot over the course of billions of years, the matter began to lose all the energy it acquired during the Big Bang, and as that matter lost energy, it cooled, allowing for the formation of the particles from photons that make up all the known atoms in the universe: electrons, protons, and neutrons. These charged particles fused together to make hydrogen, helium, and lithium, the three lightest elements. As time continued on and matter continued to spread away, these elements grouped together due to gravity and began forming gas clouds that would turn into galaxies. Within these galaxies, tightly packed elements formed large stars and created enough pressure in their center that they fused more charged particles together, and in doing so created all the other elements we see today. In time, these stars would run the course of their lifespan, condense, and shoot their own matter out into space. In a tiny portion of the Milky Way galaxy, our sun was formed through the collection of light elements. Every bit of matter in the area began to get pulled towards the sun due to its gravitational pull. Bits moving, rotating towards the sun would collide and join together to form our planets. And here's where geology comes into our understanding of the history of everything. As our planet was being formed, it was a highly volatile climate with rocky material and heavy elements remaining in liquid state, and as the convection heat of all the material was so hot solids could not form. Heavier elements such as iron, nickel, and lead gravitated towards the center of the gravitational pull and began to form our planet's core. Over time, the surface was allowed to cool and solidify, with lighter gaseous elements forming our atmosphere. Fast forward to modern day. We experience earthquakes and volcanic eruptions, all because the elements in the core of our planet remained warm from the time they collected in our planet's center. The energy contained within the heat of our planet can be traced back to when these elements were formed in another star, and even further back still to when all the matter was in a single point smaller than a ballpoint pen. Tectonic plates move over the mantle of our planet due to convection cells. As these plates move, bump, and interact, oceanic plates, which are composed of more recently formed rock, always submerge under continental plates because of their density. Oceanic plates are formed from more direct input of magma cooling rapidly on Earth's surface, so they tend to be composed of heavier elements such as iron and magnesium that would otherwise be found intrusively. These plates subduct under lighter continental plates, and the water trapped within the plate being dragged down rises after it reaches a certain temperature and forces the creation of volcanoes. These plates also slip and release tension through earthquakes. So there you have it, an example of how science is always interconnected and why our earthquakes and volcanoes are a result of the Big Bang. Boom. Cool, okay.